Okay, I'm back again. This next problem says divide and simplify the radicals by using the quotient rule for radicals and rationalize the denominator if necessary. So, using the quotient rule for radicals, remember how with multiplication we could break it up. In this case, we could do the same thing. I could combine it, instead of breaking it up because it's already broken up, to being 45y over 5 like that. Now here I can actually just go ahead and divide the numbers, which is what I want to do, and make this the square root of 9y, like that. I don't have a denominator anymore. In this case, I don't have y to any power besides 1, so I can't, take this out of the radical. But the 9 I can take out of the radical. We already know the square root of 9 is 3, so I get 3 radical y. That's my answer. Number 8 says simplify or state that it's not a real number. In this case, as you can see, the negative sign is on outside the radical. If it was inside the radical like this, where you have negative 36, this is not a real number. So this is not a real number, okay? We don't really go into this in this class about what this number is. You will learn about it more if you take college algebra or something like that. But in this case, what you're going to do is I would just simplify the square root of 36, which is 6, and then this negative sign is just going to be on the outside, okay? So it ends up being like that. Answer, negative 6. It's okay. Look at the next one. It says simplify the expression by combining the radicals using indicated operations. Do you remember one of the earlier problems, we had to actually change around the radicals to be able to add and subtract them? Here, they're already the same. Because they're the same, I can just go ahead and literally subtract my numbers, 5 minus 8, which is minus 3, and then this radical 11y just comes along. This next one says simplify by rationalize the denominator. Now in this case, I can't do that trick that I showed you where, in this case, I can't do the trick where I showed you where you do like this, and then you have like 8 over 2, and you go on, because this 8 doesn't have a radical. So I have to rationalize it. Rationalize it means we have something in the denominator that has a radical, has a square root sign. We don't like it. We don't want it there. Okay? We can't do anything with it. So I take this and do the square root of 2. Now to rationalize it, what you do is you multiply the top and the bottom here by whatever this is. If it's square root of 3, square root of 11, whatever. So multiply the top and bottom by the square root of 2. Now what happens when you multiply two square roots together and they're the same? Square root kind of disappears. Okay? So here I get 8 times square root of 2, which is just 8 square root of 2. It just comes along. And here, because you're multiplying by the same number inside the radical disappears. Cancels out. So I just get 2. Now I need to simplify 8 over 2, which is just 4. And the radical 2 doesn't change at all or go away. It stays there. That's my answer. Okay. Let's look at the next thing. Next one says simplify the following expression. This is a fractional exponent problem. So first thing we want to do is rewrite this like we talked about from before, where I have this, and I fill in my root, and I fill in my power. Okay? So to do this, here's my radical. My 36 goes underneath it. This is my root. This is my power. So basically, this is just saying the square root of 36, because the 1 isn't really going to do anything, and the 2 isn't, that's what square root is. So this just ends up being the square root of 36 with an answer of 6. Now, this one right here is asking us to evaluate this and write if it's not a real number. Remember what I just talked about, if it's a negative underneath, it's not a real number. So this is not a real number. Some teachers will show you about imaginary numbers. So if your teacher did, what they want you to do is they want you to change this. If maybe your teacher talked about, that I is equal to the square root of -1, or that I squared is -1, something like that. If you haven't seen anything that I just wrote about these i's, totally ignore what I'm talking about. But if you have, your teacher might expect you to know that the square root of 81 is 9, okay? And so you'd have 9, but you wouldn't have -9, you'd have 9i. The I kind of takes care of that negative sign, okay? So, some teachers might say this is okay answer. Some teachers might want this. You should know which one your teacher is. If you've went over this in class, then your teacher wants this answer maybe. You want to verify with them before the test if this kind of question is going to be on there or not. Or if they just want this answer. Okay, this next one says simplify the following expression. So this is one where we again have to break this down completely. So this is a cube. So if you remember, I talked about earlier about the cube power. So 4 cubed is 64. So I know 4 is something I want. I've been saying, wait a minute, that's negative. Odd powers or odd roots, cubed root, 5th root, 7th root, or something to the 5th power, 7th power, 9th power, you can have negative answers, okay? Or you can take the root of a negative number. So here, I have the cube root of negative 64, and I also have the cube root of x to the 9th power, okay? And I already know that the cube root of negative 64 is going to be 4, but negative, because it's negative here. That's okay. Now again, I want to treat this like division. 3 goes into 9 how many times? Just 3. No leftovers. So this just becomes x to the 3rd power. So negative 4x to the 3rd power is my answer in this case. That's it. Now this next one down here says solve the following, or write if there's no solution. Okay? So let's go ahead and solve this. How do we solve this? If you remember, what I talked about was that whenever you took a radical and you multiplied it by the same radical, like this, the radical signs disappear. Well, the same thing would happen if I did the square root of 2 and I squared it. Then I would get just what's underneath 2. Those two things cancel out the radicals. Well, if I notice, where is my variable, my y, trapped? Under a radical. I need to get rid of the radical before I can move y. So to do this, I'm going to have to square this whole thing. I'm not going to multiply by square root of 3 minus 2y. That's going to get icky. Okay? So I'm going to square this side. That's going to take care of my radical. But what I do to one side, I have to do to the other. So I have to square both sides for it to be the same. Okay? So make sure you're doing this on both sides. On this side, it cancels that. So I'm just left with what's underneath, 3 minus 2y. Over here, I do need to go ahead and square this and get 9. Now, this is just like your normal solving for y, easy solving for your variable, you know, things that we've done in the past. So you just minus 3, minus 2y is equal to 6. Divide by negative 2, divide by negative 2. Y is equal to negative 3. Now, to get this answer, okay, one thing you always want to do is go back and see if it works. Sometimes whenever you're doing these, you might get 1 or 2 answers and they might not work. So you always want to go plug them in. Back to the original. So let's do that over here, okay? So I'm going to go ahead and take this. So square root of 3 minus 2 times negative 3. Will this end up giving me an answer of 3? I don't know. So I get the square root of 3. This becomes a plus 6 equals 3. This becomes the square root of 9. That does equal 3. This does work out. So this is the correct answer. Okay? Always check those answers in this case. It's very important that you do that. Now, very last problem. It says solve the following radical equation, or if there's no solution, write no solution. So again, a very similar setup, except I notice this is not under the radical sign. You want this problem to start out as something under the radical equals a number. You don't want to have a plus 3 or some other stuff over there. You just want it to be radical equals number, then you can go ahead and start squaring your stuff, okay? So in this case, I need to actually move this over there. So I'm going to subtract it. So 4 equals, I'm just going to write everything out. So I'm going to minus the 2, and I get 2 is equal to the square root of minus 2 minus 6u. Now I can square both sides. Remember, the squares cancel that out. This becomes over here 4. And I have minus 2 minus 6u. Now I just go ahead and start solving. Easy stuff. Plus the 2, plus the 2. I get 6 is equal to minus 6u. I divide by negative 6. And I get negative 1 is equal to u. I'm going to go ahead and circle it, but we're going to go see if that works. I got to go back and plug it into the original, not to any of this stuff down here. Okay? So is 4 equal square root negative 2 minus 6 negative 1 plus 2. I want to see, is this going to work, okay? So 4 equals, here I'm going to get a plus 6. So square root minus 2 plus 6 plus 2 4 equals minus 2 plus 6 is going to give me a positive 4 plus 2. Square root of 4 is equal to 2 plus 2. This does work out. I do get 4. This is the correct answer here. Okay, I just want to wish you guys good luck on this test for Chapter 8, going over radicals. And good luck with that. Just remember to practice your problems. Know, those square roots and those perfect squares and those cube roots and those perfect cubes, and write them down on your note card.